A buck regulator is a DC-DC converter which converts a higher voltage potential to a lower voltage potential. It uses a switching element to ensure steady DC output of the required voltage. I am Reshma and today we will discuss the operation of a buck regulator. In this video today, we will look into the transfer functions of a buck regulator in continuous conduction mode. They include voltage transfer function, inductor current balance method, voltage transfer function, inductor voltage balance method, current transfer function. In our previous videos, we have seen that when the switch is turned on, the rate of change of inductor current is given as Vin minus Vout into D into T total divided by L. Under ideal conditions, Vf, that is the diode voltage, is equal to 0 volt. Then the rate of change of inductor current is given as minus Vout into 1 minus T into T total divided by L. For an inductor current in steady state, the change in inductor current during switch turn on must be equal to the change in inductor current during switch turn off. This means that the net change in inductor current is equal to 0 amps. That means DIL on plus DIL off is equal to 0. This is called as the inductor current balance. On substituting the known values, we get this equation. Here, we can cancel out the common terms. On cancelling out the common terms, we get this equation here. Let us now simplify the equation. We get Vin minus Vout into D plus minus of 1 minus D into Vout is equal to 0. On simplification, we get Vout is equal to D into Vin. Here, it can be observed that the output voltage is dependent only on the input voltage and duty cycle of the operation. It is independent of inductor value and the switching frequency. Let us now look at the inductor voltage balance method. We know that when the switch is turned on, the inductor voltage is given as Vin minus Vout. When the switch is turned off, the inductor voltage is given as minus Vout. For an inductor in steady state, the average voltage across it is equal to 0. This is called as the inductor voltage balance. Hence, total voltage across the inductor over T total is equal to 0 volt. This means 1 by T into VL on T on plus VL off T off is equal to 0. On substituting for VL on and VL off, we get 1 by T into Vin minus Vout into T on minus Vout into T off, that is equal to 0. Let us now simplify the equation. We know that T on is equal to dt and T off is equal to 1 minus d into T, where T is the total time. Let us substitute this in the previous equation. We get 1 by T into Vn minus Vout into dt plus minus of Vout into 1 minus d into T, that is equal to 0. Let us now take T as the common term. T and T get cancelled out. On simplifying, we get Vn into D minus Vout into D minus Vout plus Vout into D is equal to 0. On further simplification, we get Vout is equal to Vn into D. Here, it can be observed that the output voltage is dependent on the input voltage and the duty cycle of the operation. It is independent of the inductor value and the switching frequency. Let us now look at the current transfer function. For a lossless system, input power is always equal to the output power. Then Vn into In is equal to V out into I out. Input current is given as I in is equal to I out into V out divided by V in. However, we know that V out is equal to V in into D. Then D is given as V out by V in. Substituting the above, we get I in is equal to D into I out. In this video, we saw the equations of voltage and current transfer function of a buck regulator in continuous conduction mode. We will learn more in our subsequent videos. Until then, let's keep exploring and learning. Thank you.